The first of the shortcuts that we can use to prove that triangles are congruent to each other is called SSS, which stands for side, side, side. So what we're going to be looking for is whether or not we can prove all three sides of these triangles are congruent. If we can do that, we can say that the triangles are congruent. So in our first set of triangles, I can see that because of tick marks, I do have all three pairs of sides matched up. Side QT is congruent to side TR, side PQ is congruent to side SR, and side PT is congruent to side ST. And so, yes, this first picture is an example of side, side, side. And when I want to explain why, well, I would just write out what I just said. QT is congruent to TR, and so on. As far as writing our triangle congruency statement then, we had said in class that the order of the first triangle doesn't matter, but my rule of thumb is do that first one alphabetical. That will make my life easier when we grade it. So the triangle on the left, if we consider that the first one alphabetically, would be triangle PQT. I then need to match that up, and the second triangle may or may not be alphabetical, so just make sure things match up. For example, angle P matches up to angle S, and if I finish this out, that would be SRT. So yes, those two triangles are congruent by side, 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 and that would be my congruency statement. Our second set of triangles don't have any tick marks, but I can see that I can add some. For example, AD and BC are both labeled as 7, so I can get that side matched up. Also, one thing that we'll be talking about a lot with proofs is this side right down the middle. Both triangles share that side AC, so I can add a tick mark to that side. What we'll be calling this, as we start to write our proofs, is an example of the reflexive property. Something is always congruent to itself. So if two triangles share a side, or sometimes they'll share an angle, we can say that that side is going to be congruent. So I have two pairs of sides matched up. However, for side, 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 I need the third side matched up as well. And I can see that that third side is not going to match up. AB and CD are not going to be the same length. So these two triangles are not congruent. They're not congruent at all. They're definitely not congruent by side, side, side. I don't have all three sides the same length. And in our final example on this screen, once again I can see that I have two sides matched up. KL and LN are congruent, and KM is congruent to MN, but I don't have that third side. But remember what we just talked about was if two triangles share a side, which in this case they do, I can always add a tick mark to that side. The reason is because of the reflexive property. So once again, that's why I can add that tick mark. If I look now, all three sides have tick marks, so yes, I can say that these two triangles are congruent by side, side, side. All three sides are matched up. And again, if I want to write my congruency statement, let's do the first one in alphabetical order. So KLM. And then notice it's a reflection this time, so make sure that things match up. K matches up to N, and then LM. In our next set of problems, we want to see what additional piece of information are we going to need in order to use side, side, side to prove the triangles are congruent. So in these problems, we don't have enough information. We can't prove the triangles are congruent, but the question is, what else would we need to know? And so in order to use side, 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 SSS, I need to have all three sides matched up. Well, I can see in the first diagram that I have two sides matched up already. And so the third piece of information I would need is that third side. And so I would need to know that segment BE is congruent to segment ED. And again, just to clarify, I don't know this. There's no way that I can prove that, but that's the question. That's what I would need to know in order to prove these triangles are congruent by side, side, side. In our diagram on the right, it looks like we only have one pair of sides matched up, AB and AC. But remember, they share that side, so because of the reflexive property, I can add a tick mark on that side. So I actually already have two pairs of sides matched up. So again, in order to use side, 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 I would need the third pair of sides congruent, which this time is going to be the bottom side BD and the other bottom side DC. So again, to clarify, I don't know that those two pieces are congruent. That's what I would need to know in order to use side, side, side. And finally, in these last couple examples, we want to see is the congruency statement they wrote true. So there's two things we need to check for. One, we need to check and see if the triangles are even congruent. And at this point, the only shortcut we have is side, side, side. The second thing we need to check for is the congruency statement they wrote in the correct order. So two things to check for. In this first triangle, I can add that tick mark for reflexive property. And I can see that those sides match up. They're both 9. These sides match up. They're both 8s. And so yes, the triangles are congruent by side, side, side. But check out the congruency statement they wrote. That's the other thing we have to check for, and sometimes this is really sneaky, so watch out. The order of the first triangle is JKL, so if I trace that out, I start at J, I go to K, and then I go up to L. If you trace out the order of the second set, I start at M, I go to L, to L, sorry, and then to K. And so I can see that I'm not tracing these in the same exact order. So even though the triangles are congruent, the congruency statement is not correct. It's not in the right order. And so what I might want to do for this one is, just to clarify my answer, is I'm going to say yes, the triangles are congruent because of side, 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 but the statement is wrong. And so maybe I want to fix their statement. And so rather than MLK, I'm going to match that up to MKL. And so the triangles are congruent, but the statement is wrong. The set of triangles on the right, I can see that all three sides are matched up. I just want to check. So yes, the triangles are congruent by SSS. So yes, oops, sorry. Yes, triangles congruent because of SSS. Let's just check the order of the congruency statement. What might be helpful in this case is to redraw one of the triangles to see if these are matched up correctly. And so let me go ahead and redraw this first triangle so it's oriented like the triangle on the right over here. And so I'm going to put that single tick mark on the bottom, which means that's R, and that's S. I'm going to put the triple tick mark over here, which makes this, sorry, having some problems here, which makes that T on the top, and the double is over there. So now let's see if we have things in the right order. So I'm tracing this out as R, S, T. So I'm going R to S to T, and I want to see, is that the same as T to V to W? Yes, that goes in the same order. So this is totally fine. The triangles are congruent, and their statement is written correctly.